Have you ever pondered the end of time, the ultimate fate of our vast universe? This is the question that has intrigued and baffled the greatest minds of humanity for centuries. Today, we delve into this enigmatic topic, unearthing theories that attempt to explain the destiny of our universe. This isn't your ordinary science lesson, though. It's a journey into the speculative, a plunge into the mysteries of existence that lie far beyond our current understanding. We'll tackle concepts like the heat death and quantum fluctuations, and even dare to question what might exist beyond the boundaries of our known universe. These are theories that stretch our imaginations to their limits, challenging us to rethink everything we thought we knew about space and time. But don't be daunted. The unknown is, after all, just the known waiting to be discovered. So, fasten your seatbelts as we journey into the realms of the unknown, the speculative and the extraordinary. Imagine a universe that has cooled down to a point where no more change is possible. This is the idea behind the heat-death theory. Let's delve into this chilling concept. Picture this: the universe as an enormous cup of coffee. When you first pour it, there's a lot of heat, a lot of energy. But as time goes by, the coffee cools down, losing its energy to the surrounding. That's entropy at work, a fundamental law of physics that states that energy naturally spreads out if it's not hindered from doing so. Now apply this to the universe. The stars, the galaxies, all the celestial bodies are like that hot coffee brimming with energy. But just as the coffee cools down, so too does the universe. Energy is spreading out, stars are burning out, and galaxies are drifting apart. This leads us to the heat-death theory. It proposes that the universe will continue to expand and cool until it reaches a state of maximum entropy. This means that the universe, once hot and vibrant, will become a cold, dark, and quiet place. Everything will be spread so thin that no significant events can occur. Stars will no longer shine, galaxies will be isolated in their own pockets of space, and even black holes will have evaporated. But what does this mean for time? Well, time is linked to change, to the flow of events. If the universe reaches a state where no events can occur, where there's no change, then time, as we understand it, becomes meaningless. It's not that it stops, rather it loses its purpose. And so we are left with a universe in equilibrium. Every bit of matter, every bit of energy, perfectly spread out. No more change, no more time, just an eternal state of equilibrium. In a universe dictated by heat death, time as we understand it would cease to exist, leaving behind an eternal state of equilibrium. Now let's shift gears and consider a universe that is not dying but rebirthing, driven by quantum fluctuations. Quantum fluctuations, you see, are the temporary changes in the amount of energy in a point in space, as allowed by the Heisenberg's uncertainty principle. This principle from quantum mechanics suggests that there's a limit to how precisely we can know both the position and momentum of a particle. So, in simpler terms, on the tiniest scales, the universe is a bit like a frenzied dance party, with particles popping in and out of existence. Now imagine this dance playing out on a cosmic scale. Some scientists theorize that our universe could be just one phase in an infinite cycle of expansion, collapse, and renewal. This is the concept of the Big Bounce. According to this idea, our universe might have sprung into existence not from a singular Big Bang, but from a previous universe collapsing under its own gravity. The Big Bounce theory challenges the traditional view of time as a straight line stretching from the past to the future. Instead, it suggests that time might be a circle, a loop that we're endlessly traveling around. In this scenario, the end of the universe is also its beginning. The death is a birth. But how does this happen? What drives the universe to bounce back after collapsing? The answer could lie in the quantum fluctuations. After the universe collapses, these fluctuations could cause it to expand once again, creating a new universe in the process. So what does this mean for us, for our understanding of the universe and our place in it? Well, it suggests a cosmos that is constantly in flux, a universe that is not static, but dynamic. It hints at a universe that is not simply born and then dies, but one that is born, dies, and then reborns. If the quantum fluctuation theory holds, Time might be a never-ending cycle, a cosmic dance of birth, death, and rebirth. But what if our universe is not alone, but one among many, each with its own laws of physics and its own fate? This is the question that drives the multiverse theory. It's a concept that challenges our very understanding of reality and time. The multiverse theory posits that our universe, the one we experience and measure, is but a single bubble in an infinite cosmic foam. Just as there are countless bubbles in a bath, there could be countless universes in the cosmic ocean. Each of these universes, or bubbles, may have its own unique laws of physics, its own dimensions, and its own timeline. Imagine the implications. Time, as we understand it, is bound by the physics of our universe. If each universe has its own unique laws of physics, then the nature of time could be drastically different in each. It's like visiting a foreign country where the local customs, language, and even the sense of time are different from what we're used to. This also brings us to ponder the end of time. In our universe, we speculate about concepts like the Big Freeze or the Big Bounce. But in a multiverse, the end of time might not be an end at all. Just as each universe could have its own unique beginning, each could have its own unique end. The death of one universe might be the birth of another, a ceaseless cycle of creation and destruction, beginnings and ends, played out across an infinite cosmic stage. In fact, if there are an infinite number of universes, then every possible outcome, every possible history, and every possible future might be playing out somewhere. The end of time in our universe might be just another tick of the cosmic clock in the grand scheme of the multiverse. This is the beauty and the mystery of the multiverse theory. It broadens our cosmic horizons and challenges our understanding of time and existence. It's a theory that's still highly speculative, but one that's tantalizingly intriguing. In the grand scheme of a multiverse, the end of time in our universe might just be another beginning elsewhere. As we delve into these theories, it's important to remember how much we don't know. This simple truth, while humbling, is also incredibly invigorating. It's a testament to the limits of human knowledge, a reminder that despite all we've learned about the universe, there's still so much more to uncover. Our current scientific understanding is a mere speck in the cosmic sea of knowledge. Our theories, hypotheses, and models have allowed us to make great strides, but they are, at their core, our best educated guesses. We're like children in a dark room, groping our way around, trying to make sense of the shapes and shadows. We use speculation as a tool, a compass to navigate the unknown. It's speculation that led to the Big Bang Theory and the concept of dark matter. It's speculation that drives our curiosity and propels us forward in our quest for understanding. Speculation is also a double-edged sword. It can lead us down fascinating avenues of thought, but it can also steer us into a labyrinth of uncertainty and confusion. This is why skepticism is crucial. It's the counterbalance to speculation, the force that keeps our feet firmly on the ground while our minds soar through the cosmos. It's skepticism that pushes us to question, to challenge, to test, and retest our theories until we're as confident as we can be in their accuracy. Yet even with this rigorous approach, there are truths about the universe that remain elusive. While we may have an understanding of how stars are born and die, the nature of black holes, or the expansion of the universe, we are still grappling with questions about dark energy, quantum gravity, and of course the ultimate fate of the universe. So as we continue to probe the mysteries of the cosmos, we must remain humble, skeptical, and above all, curious. For it is in the pursuit of the unknown that we truly test the limits of our knowledge and our capacity for understanding. As we continue to gaze into the cosmos, the end of time remains one of the greatest mysteries, a tantalizing enigma that keeps us forever curious. So, is the end of time a definitive end or just a new beginning? Let's take a trip down memory lane. Remember the Big Freeze? It suggests a universe gradually cooling until motion itself ceases. Then we have the Big Bounce theory, proposing that our universe is just one in a cycle of expansion and contraction. And let's not forget the multiverse theory, hinting at countless universes existing beyond our own, each with their own laws of physics. Each of these theories paints a different picture of the end, But what they all share is a sense of continuity, a transformation rather than a full stop. They remind us that for every end, there could well be a beginning. But here's the real kicker. We may never know for certain. The true nature of time and the universe may forever remain a mystery, just beyond our grasp. It's these questions that make us human, that drive us to explore and understand. So, until the end of time, keep questioning, keep wondering, and keep exploring the cosmos.